our class today. Uh, Today we are going to discuss some problems about bevel and worm gear. Yeah. Determine the forces in the bevel and worm gear, and also how to design the bevel and worm gear based on ACMA bending or up or an ACMA surface. Okay, let me. There are 5 students here that will be uh, present their answer and explain it. Yesterday Mbak Salwa text me. She said that he wanted to present for the first time because she some appointment at 8 or 8:30. So I think Mbak Salwa is a woman maybe, yeah. So she has another. So let's start with Mbak Salwa. Mbak Salwa already in here or not?
Oh, yes, sir. Wait a minute. I will change the connection because this connection is unstable.
Okay. Okay, and after Mbak Salwa, then we continue to another one. But should be so after Mbak Salwa, we will continue to Mas Faisal and then Mas Dimas, Mas Andika, and Mbak Agnes.
Let me share screen, sir.
Okay.
Okay. I will discuss about problem 5040. And from the problem, we know that this is a single thread cell worm that rotates and messing with the gear, this horsepower, output shaft, and pitch diameter, tangential, and normal pressure angle, ambient temperature, application factor, design factor, gear face, and lateral grace area, and the material of gear. So we need to determine and evaluate the geometric properties of the gear, determine the transmitted gear force and the mass efficiency. Is the mass sufficient to handle the loading, and estimate the metric lateral pitch, diameter of gear, center to center, addendum, dedendum. We know this from this equation. And then we can calculate the full depth diameter from this equation, and some of this is the geometrical properties too from the gear and the worm. And we know the phase wide maximum of worm, and the tangential velocity of the worm and the gear with this equation, but the change in the end of this is
from the problems or from
okay.
the
The
calculation?
ratio, the ratio is we of tooth
Mm-hmm.
in the worm is ratio with the number of the number of tooth in year. This is the worm is single thread steel worm, so this is with the n is 1, and this is 56 in the year, so the end of year is 56, like that.
Oh, okay. So the ratio is 5:6, yeah. Okay.
Yes, sir.
Ratio is 5:6, and then so the rotation, yeah, the velocity also the ratio 5:6 also, yeah. The velocity.
This velocity, sir.
Yes, ng is 330 something. How about nw? Nw is,
NW.
no, I mean rotation, worm rotation.
This is, sir.
Oh, 1725. Okay, 1000. So this is reduced, yeah. Is this reducing or increasing speed, Mbak Salwa? This worm
Uh, Reducer.
reducing, yeah. So reduce from 1700 something, yeah, nw
Yes, to
into
this
30 something.
30.
Okay, with ratio 56. Okay, okay. Then you can
Mm.
you can continue, Mbak.
Okay, from the equation, this equation, we know that the uh, axial circular pitch and the diameter of the gear
Mm-mm.
this with this equation. So we can calculate the center to center. We know that the diameter of gear and the diameter of worm in here,
Mm-mm.
we
Okay.
can sum and uh, like that. So we can calculate the addendum and addendum with this equation.
Okay.
This is the full depth. We know that the axial circular pitch of no in here 1.4, so it's larger for the 1.16. So we know that the full depth is equation. And then you can calculate the worm outside diameter and worm root diameter, worm gear-throat diameter, and worm gear-root diameter, and the last is the clearance. The next is you need to calculate the worm face width maximums with this equation. From here, we can get the diameter of gear and the addendum. Can input the diameter of gear and addendum in here. So you can get the 5-weight maximum of worm is 2.6. And this is the tangential velocity. This is you can get the tangential velocity of worm and tangential velocity of gear. The difference in you need to input the tangential, the radial velocity in the worm and the shear is different like that. This is the lead you can get from this equation, and this is the tangential lead with this. The lead is in here. This is the lead, and this is lead angle that we calculate before. Okay, the next is sliding velocity. We need to search the sliding velocity to calculate the next step. Like this, the ACMA you need to calculate from sliding velocity. From the sliding velocity, you know that sliding velocity is like 118, so we need this question. With this equation, we can get the coefficient of friction of this. From the equation of friction, we can get the efficiency of the worm, because this is from worm to shear. So we can use this
Salwa,
equation.
what is the first question? What's the first question?
The first question is geometric properties.
Geometric properties.
Yes. Until this is the geometric properties.
Can you show the slide number 4, that we see the list of questions? Oh, geometric properties. So in your answer, the properties is including diameter,
Yes,
face
sir.
width.
Yes.
What else? Diameter, face width, pitch,
Addendum,
lead.
lead. Yes.
Lead. Okay, angle, lead angle. Okay, and then the next one is transmitted gear force and the
Yes.
mesh efficiency. So how we determine this transmitted gear force and mesh efficiency?
This is the calculation of the efficiency because of the problem is from worm to shear. We use this equation, efficiency of worm, like that. So we need to find the coefficient of friction from here, and we calculate from this. Before we know that coefficient of friction, we need to calculate the sliding velocity. That's why we need to calculate this before we can get the efficiency of the work. And the second
transmitted force
is yes, transmitted force of the shear and warmth. From this, we can get in here. This is have known before, like. So the next question is we need to calculate is the mass will survive or not, like that. So we need to calculate with this equation. Before of this, we need to determine the material factor and friction factor, and the last is velocity factor. We can calculate from this. This is the because of the material of the gear is sun case from some case manufacturer, so we can determine the material factor from this equation. And this is the ratio correction factor. Because of the ratio is 56, we choose this equation and get the ratio correction factor. And last is velocity factor. From the sliding velocity that known before, that we can get the 600 600, yes, 618. We use this equation to find the velocity factor. From that we can get the allowable tangential force in here. This is the allowable tangential force, but the allowable tangential force is lower than tangential force in the gear, so the mass will not survive.
How about the tangential force in worm? It's
And the
bigger,
tangential,
bigger than.
this is the tangential is 100. So yes, this is the bigger than the tangential force in the worm.
In order to determine this the mass is survive or not, only compare the WT all with WTG, not with a worm.
This honestly, I still confused about that,
Okay.
because the this problem is the same with the example 53 in here, sir. From this, we just know from the equation of this.
Okay.
But
Okay.
they continue until get this. So I still calculate them, but I still confused about this. Like that, sir.
What is this?
The continue
The
of this.
this is the horsepower, the rate
Yes,
power.
yeah, but the horsepower is still needed from this to get.
Okay, so let's go to the next question.
Okay, the next question is we need to determine the lubricant sum temperature. And with this equation, we need to find the heat loss, and then overall coefficient for combined convective and radiative heat transfer in here, and ambient temperature we can know from the problem. So we need to find the heat loss. This is the heat loss. From the heat loss, we can get from this equation with the input of heat input in here is from the worm, because the worm is the input. We can get from this equation. From 2.1 this Earth's power, we can input to this equation and get the heat loss here. And from here, we need to calculate this overall coefficient in here with because of the problem is there's no keterangan, Pak, mohon maaf, keterangan bahwa itu ada fan-nya atau tidak, maka saya menghitung keduanya seperti itu. And we can get this temperature of the sum for no fan and with fan in here.
Okay, Mbak. Okay, so what is the difference, ya, Mbak, ya? What's the difference between helical gear and worm gear in terms of the was that? The I don't know. It's term of anything. What's the difference? What's the difference in terms of efficiency, in terms of temperature, in terms of maybe the ratio, maybe the velocity, yeah, velocity in warm, velocity in cave. Did you notice any difference between any big difference between uh, spool gear, helical gear with this warm gear, Pak Samuel?
I think the difference is in the ratio. So in here, in the worm is very big in ratio, and but the helical is not too as big as 56 like this. So the velocity will the decreasing and increasing of the velocity is very big like that.
Okay, okay, that's the number one. Next one, next difference.
I think the the direction of force, because the helical we need to determine the direction first, but the equation of the worm is still
Sorry, Mbak. Can you repeat again?
I think the equation for the worm equation of the worm is still the same. We don't need to determine the direction of force like that.
So what is the difference in terms of force in in
Uh,
helical gears?
in helical, we need to determine the direction of the force first, so we can know the force in the gear is different with the other gear system. Like that, sir.
That's in helical.
Yes, that's in helical.
And how about the worm?
The worm is the same.
Oh, same. So my question is, what is the difference, Mbak?
Gimana ya, kalau di helical itu kita perlu menentukan arah-arahnya gitu, Pak. Arah-arahnya dulu di sistemnya itu bagaimana, terus baru menentukan equation-nya dari situ.
Kalau di worm,
Sedangkan kalau di worm semuanya equation-nya sama gitu, Pak. Jadi kita tidak menentukan arah karena sama gitu, Pak.
bukan. Sepertinya bukan.
Oh, bukan ya.
Try another one ya. Apalagi yang kelihatan. Efisiensi, how about efisiensi, Mbak Salwa? We also need to calculate the efficiency in helical gears, or we also see any efficiency value in helical gear? Efficiency. In here, your efficiency is 0.75 ya, 75%.
Yes, sir.
Seperti efficiency is output per input kan, ya, output per input, right? So it means if you have a output per input, ya, 4 horsepower in the input, 4 horsepower, and then the output is only 3 horsepower, yeah. So
Yes.
Is it also happen in the helical gear?
I think on the helical gear is there's no efficiency.
No efficiency.
Yes, sir.
100% maybe, yeah. Not exactly 100%, but almost 100%. Maybe 98, 97, or 99% something.
There's no efficiency in helical, sir.
No, yeah. In the calculation, we never calculate the efficiency, but
Yeah.
in reality, in
In
reality,
reality, I
the
think we still there's there's still friction in the
friction,
gear
okay,
in
in
every
helical gear.
gear, so we need to calculate the efficiency
Okay,
like
okay.
that, sir.
So then my next question is why in a in warm gear set the efficiency is less than in the another another types of gear, yeah. What
Oh,
happened? What happened? Another. Um,
there's because the ratio of the worm is uh, very big, so the worm is need the butuh kerja ekstra gitu loh Pak uh,
yeah.
untuk kerja karena terjadinya kerja ekstra tersebut menimbulkan heat loss juga yang besar seperti itu sehingga efisiensinya ya cukup besar seperti itu Pak.
Oke, oke. Ya, logiknya oke lah, logiknya oke. Tapi next question is what happened in a warm gear? So then he need big energy, ya, big
Friction
extra
because of the
power
friction, sir.
friction. No, in the helical is also friction is also happen in the helical, right?
I
In the
think
spur
the
gear. What is the
friction
different the different with the friction?
the friction in the helical is because of the friction in the helical is small, so that's why
That's my question, Mbak Salwa. Why in helical is small and in warm is
oh
big?
I
What
think because
happened? What
of
happened?
the apa ya, karena arahnya yang berbeda gitu Pak di worm.
Ya, ya betul. Logikmu bagus lah, Mbak. Logikmu bagus. Tapi ya itu betul semua. Kamu tanpa membaca ya, tanpa membaca detail, kamu bisa melogik itu bagus banget sih. Tapi kamu perlu baca di dalam bukunya, textbooknya
Iya
itu.
Pak.
What happened gitu, yang membuat dia jadi apa namanya, jadi besar semua itu. Gitu. Dan di logik memang seperti itu. Oh ini rasionya gede, 56 compare with 5 or 6 in helical, so then need extra energy. Okay, that's good. And then the position between input and output is different. Yeah. In helical is in parallel, but in warm it's intersection between that we need extra energy. So then the big losses will happen, and then the efficiency will be smaller. Yeah, that's okay. But what happened in the contact between warm and gear? That's the difference between warm gear and another gear. In the contact, how to contact between gear and between warm and gear is different with how to contact in a bevel, in a spur gear, and also in helical. Okay, that's okay, Mbak Salwa. And then let we go to the next discussion. And after we know that the efficiency is smaller because there's some friction, there is heat, yeah. Then we need to give more lubricant, ya Mbak ya. Is it correct or not?
Yes, sir. That's correct.
So we need to make sure that our lubricant circulation or our lubricant inside the cover of a warm gear is enough. Then it will be reduce the heat effect of the warm gear. Yeah. And
Yes, sir.
in these problems you calculate the temperature, ya Mbak ya.
Yes, the temperature.
What is this? What's temperature? So you got 100 something Fahrenheit. So this is, what is this? Is this temperature inside, outside, or what is this, Mbak? TS. I will sum.
I think this is. I still confused about the ambient temperature in the definition of the ambient temperature. But I think the TS is the allowable temperature. So.
Allowable temperature.
Saya masih bingung Pak yang ini.
Allowable temperature. How about the ambient? Ambient temperature? What is ambient temperature?
Iya, saya bingung yang ambient.
Oh, ambient itu kan environment ya. Ambient itu environment temperature ya. Temperatur luarnya ya.
Surrounding.
Surroundingnya. Berapa nilainya sih? What's the value for T?
And the ambient temperature in here is 70 Fahrenheit. So.
In Celsius? Berapa? 70 Fahrenheit sih? Coba lihat di Google ya.
343, sir.
Oh, no. Google say 21.
Oh yeah. 2003.
20, yeah, 21. Google said to me 21, Pak.
Okay, sir.
21 Celsius, so it's a surrounding that environment temperature. So I think oil sum temperature is temperature inside the oil chamber, or inside the cover of the worm cave. Okay, I think that's enough, Mbak Salwa. It's good. Is there any question from another student?
Can I ask about this, sir? I still confused about this.
Okay,
why in here in the equation of 53 we need to calculate this? And I still confused where is this from? Where is the number of
which one? WF or H? Which one? Your question. Friction force or horsepower? All of them.
This is the time of the. Can you see my set screen?
Yeah.
The book.
Oh, the book? No, not yet.
Yes. From the book of the equation is that the allowable tangential force is bigger than the tangential force in the gear. We can the mass will survive at least 25,000 hours. I still confused where's the 25,000 hours this from? That's sir.
Yeah, from textbook.
Yes.
I think it's coming from the problem, yeah, Mbak. It's not so up in the problems.
There's no, the problem is like this. There's no about the 25,000 hours.
Oh. Or maybe from the equation in the textbook. No.
There's no
information also. So you said in the solution manual, it state
I'm not
25,000. What is the source for 25,000? Is from the solution manual or from textbook?
No, from the textbooks. From the example in the textbook.
So you need to see the problems for the examples, Mbak.
There's no, the example of the textbooks is like this, like this problem. So there's no
Wait. Let me see the textbook.
25,000 hours.
Hmm. Which example, Mbak? What number?
Example 53, sir. 53.
Page number.
Page 814. Eh.
So this is the example, yeah.
Yes.
And then 25,000 is coming from
Page
page
1816, sir.
1816. At least 25,000. Maybe it's coming from the equation, but nothing, no information in the question.
No, sir.
Really. So usually we determine the life, yeah, is coming from the rotation times by what's that, the operation hours, yeah. Each day the worm gear will be operate maybe 8 hours or 10 hours or maybe 20 hours or 24 hours, and then multiply by day, yeah, number of day. Maybe it it will be easy if we say that this worm gear is rotating every day until 3 years. So then it will be easy, right? So 3 times 3 years times 365 days times 24 hours. That will be equation to something. That's the how we determine the life, but 25,000 hours. So it's depend on the operation condition, yeah, operation condition.
So from the problem, if we know that the tangential force in gear is lower than allowable tangential force, we can calculate the lifetime of the worm.
No.
So the the conclude of this is just it will survive or not, like that, sir.
Yeah, survive within 25,000. Yeah. Within 25,000, it will be survive. But if we still operating the worm gear after 25,000, then will be another parameters will be affect the life of the worm gear.
Okay, sir.
But I also didn't find any information about 25,000. Okay.
Okay, that's my question, sir.
Okay. Lesson 15.
This is
Okay.
enough, sir.
Another students. Other students, do you have any questions? No question. Okay. Thank you, Mbak Salwa. You can close the.
Okay, thank you, sir.
Cool. Let me go to next student, yeah. Mas Faisal, ya.
Let me share screen first. 'Cause, uh, 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 let me share screen first. 'Cause, uh Okay. Today I want to explain about the problem 1434. So the question is: the figure show a 16T 23 straight bevel pinion driving a 32T chair and the location of the bearing satellite. Pinion shaft A receive 2.5 horsepower at 2040 revolution per minute and
200
determine
mas.
ah
200 horsepower.
sorry 240 revolution per minute. Determine the bearing friction at A and B. If A is so, take gradual and thrust low.
Where is the A and P, mas? Where is A and P in the figure?
In
Where is A and P?
the A is the this shaft.
Really? From the problems.
A. This
No, that's a sub, mas. The question is determine bearing reaction at A and B. My question is which one is A and which one is a P? Bearing reaction A and P. For the shaft is a small a and small p, mas.
Oh
In the
yeah,
question is a capital A and capital P.
yeah.
So where is A, capital A and capital P?
In this
Okay. So those bearing A and bearing P is located in which shaft?
A.
Located in shaft A. And how about another shaft? Shaft P. For
Yeah.
shaft P, is there any bearings in the shaft P, mas? Is there
Um.
any bearings in shaft P?
In this
Only
in
one?
NC.
Okay, D and C. Okay. So, but the question for this problem is
Bearing
only
A.
bearing reaction in A and B, yeah.
Yeah.
Okay, in A and B, and in the shaft A, it is located for bevel 2, yeah. Yeah. 2
Yeah.
and 3 is the bevel number, yeah, dia. Bevel number, yeah. Gear number, yeah. Okay, gear 2 in shaft A, gear 3 in shaft B, yeah. Okay. Okay, so please continue, mas.
Okay. For the first, we calculate the input torque by using the formula. The formula is T in equal 6,000 and 60,000
25.
25 H per NA. So the H is the power and NA is the speed of the pinion. And we substitute the number 63.6325 equal 20.5. Then we get 656.5 pound force inch.
How about wait a minute? 63,000 times two should be 1,100,000 something,
Oh,
mas.
oh,
Please see the equation. If the equation is correct, then something happened with your. I think the equation is correct, but maybe your input should be checked again.
oh.
I think the rotation must rise up
Rotation.
from the equation. Look.
Conjugation. Oh yeah, I forget to input the speed of the pinion in
Okay.
after this.
What's the value for speed of the pinion?
2040. 240.
240 RPM ya?
Yeah, revolution point RPM.
Okay, so okay then next after you cut the torque, the input
Okay.
torque.
After that, we calculate the tangential force by using the formula tool. So R in here is the radius. Then we substitute the hasil yang sebelumnya dari yang
The
kalkulator.
radius is already stated in the question ya?
Yeah.
Radius.
Yes, sir.
Okay. Then after that you
And
cut
after
the
that, we got
tangential force.
the force is 328.255 force. After that, we calculate the pitch angles with gamma equal 10 minus 1 distance between gear 3 and axis Y per distance between gear 2 and axis X. Then we got here 26.565 degree, and we got it there in there is 19 minus 10 minus 1 distance between gear 3 and axis Y per distance between gear 2 and axis X. So we got 63.435 degree. After that, we calculate the radial load by using the formula. So the formula is WR equal WT and cos gamma. So we substitute it and we get this 106.86.4. Then we calculate the axial load by using the formula 2. The formula is WA equal WT and sin gamma. Then sorry. And then we calculate the load factor with W equal WRE minus WA G plus WTK. And in
So
here,
Mas Faisal, the result for WR and WA is same ya?
WR and
WA.
No, sir.
No, I see from your calculation.
Oh yeah. Saya salah tulis.
So
The hasilnya dari yang WA itu 53,43 pound force.
okay, 53. So then if the result is 53, then what happened in the load factor? It become minus ya?
Yeah.
Why? Why, Mas?
Maaf saya belum terlalu memahami ya Pak.
Ya, terus kenapa kamu tulis minus? Let we go back to 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 the problem, Mas. Let we see the figure. Okay, so let we determine the force direction. Yeah, force direction for WT, WA, WR, yeah, tangential, axial, and radial force in gear 2. So from your slide, we already know how to determine the value. Okay, we also need to determine the direction, force direction. So could you explain to us what is the direction of each forces in gear 2? Start from maybe the easy one is the easiest one is WR, yeah, WR maybe from gear 2. In which direction was WR?
Saya masih belum paham Pak.
Sudah dipelajari itu, kan tinggal dibahas,
Iya.
tinggal dipelajari. Apa yang belum paham? Apa yang belum paham? Dari yang kamu sudah pelajari, apa yang kamu belum paham?
Di vektor-vektornya ini Pak. Untuk
Lah ya, mananya, apanya yang belum paham? Kan harus kamu sudah belajar apa, terus yang belum paham apa?
Kenapa ada penggunaan vektor di sini itu saya cuma diajarkan dan saya masih belum bisa paham.
Saya enggak pernah ngajarkan vektor, makanya saya nggak bahas vektor hari ini. Saya nggak pernah ngajarkan vektor itu, meskipun itu bisa dipakai sebagai salah satu metode karena ini sumbu x, y, z-nya juga jelas. Saya nggak bahas itu, saya nggak bahas vektor. Sekarang pertanyaan saya ke sini. Directionnya FR, WR itu radial force di gear 2 itu kemana? Kamu tahu nggak cara menentukannya? WR, WT, WA itu loh, menentukannya itu bagaimana? Apa yang kamu belum tahu? Apa yang belum tahu, Mas? WR itu arahnya kemana?
WR arahnya
kemana?
arah WR tuh arahnya ke
Udah kamu tutup aja. Kamu keluar dari kelas ini, kamu delete mata kuliah ini Mas Faisal. Tutup share screen-nya, keluar dari kelas, dari Zoom meeting, delete mata kuliah ini. Ya, kita lanjutkan ke mahasiswa berikutnya. Okay, let we go to next student, Mas Dimas ya, Mas Dimas.
Sorry. Let me share screen. This is problem number 1351. The problem given a worm, right and single tooth, but it's still there is the power is 2000 watt at 600 revolution per minute and 48 tooth cast iron gear. The axial pitch of the worm is 25 millimeter. The normal pressure angle is 14 a half degree. The pitch diameter of the worm is 100 millimeter, and the face width of the worm and gear are respectively 100 millimeter and 50 millimeter. The figure shows bearing A and B on the worm shaft symmetrically located with respect to the worm and 200 millimeter apart. And the problem need to find the thrust bearing, the magnitude, and the direction of the force exerted by both bearings.
So,
This is the
question is location ya, location of thrust bearing ya Mas ya. The first question ya. Determine
yes sir.
which should be thrust bearing, it means the location kan, location of thrust bearing.
And this is the figure. This is the free body diagram.
So the question is, we have to find which force, which arrow in A, B, or G, or another in your free body diagram.
The thrust bearing is in E, sorry, A.
In A.
Yeah.
Okay. Why?
Ini karena arah gaya aksialnya.
Kenapa?
Dia arahnya kan ke Z positif. Dia memberikan apa? Gaya kompresi ke shaftnya. Jadi thrust bearingnya di A.
Apa kamu sudah menggambar axial force-nya itu?
Ini di FBD-nya ini. Ini
Ya, di FBD-mu itu loh. Apa sudah ada axial force yang menyebabkan axial force pada worm yang menyebabkan di A itu akhirnya harus dipasang thrust bearing?
Belum ada sih. Harus ini melalui perhitungan yang di bawah.
Nggak, arah gambarnya saja di free body diagram.
Ya, gambarnya ini.
Oh. Nah, terus yang di titik G itu apa?
Ini gaya yang di apa ini? gearnya.
Kayak yang di gearnya itu di mana berarti? Di lubang-lubang gear itu, warna pink itu.
Ah ya, di situ.
Bisa loh. Kok bisa muncul kayak di sana dari mana, Mas? Saya sudah mengeluarkan satu orang, jangan kamu jadi yang kedua, Mas. Free body diagram itu kamu dapat dari mana? Solman atau gambarmu?
Ini dari Salman, Pak.
Lah itu kamu harus tahu itu. Titik G itu dapat dari mana itu? Gambar di titik G itu loh. Gambar apa itu? Bukan di ping yang
Oh,
porosnya gear, bukan.
di kontaknya.
Kontaknya.
Hmm.
Sekarang cara menentukannya aksial. Betul tadi arahnya ke sana itu, Mas. Ke Z positif. Gimana cara menentukan gaya aksial pada warm gear? Tergantung apa?
Ini dari shaftnya ini.
Shaftnya warm itu kenapa?
Kan dia di sumbu Z, jadi arah kayak arah aksialnya berlawanan gitu.
Bisa loh, shaft punya arah itu loh. Bukannya dia tergantung kemiringan ya. Kemiringan warm.
Sir, excuse me, sir.
Ya, Mas.
Can I help you, sir, to try answer this question?
Oke, please.
For the pakai bahasa Indonesia aja ya, sir ya, biar nggak
Oke,
bingung
oke.
saya. Ini kan yang ditanyakan thrust bearing ya, apa bearing untuk menyangga gaya thrust dari wormnya. Ini kan worm kan right hand, sir. Right hand berarti kita pakai kaidah tangan kanan. Terus ini kan kebetulan rotasinya ke, boleh saya annotate, sir? Tapi nggak dibolehin. Belum ada akses annotate, sir.
Mas Dimas kasih akses annotate, Mas Dimas.
Sudah.
Sudah Mas Lan.
Oh, coba. Jadi ini kan kebetulan rotasinya ke sini. Tadi berdasarkan kaidah tangan kanan, itu nanti axial force dari wormnya itu ke kiri, Pak. Kiri, ini
Pakai
WH-nya.
kiri itu pakai aturan pakai cut, pakai sumbunya aja. Kan itu ada sumbunya, ada X, Y, Z. Kan?
Oh iya, ke Z negatif, ke Z positif, Pak.
Z positif.
Ke Z positif. Nah, ini kan thrust-nya ke apa? Axial force kan sama dengan thrust tuh, Pak. Thrust-nya ke kiri berarti kan biringnya kemana? Berarti biringnya harus melawan arah si thrust itu, biar kan ibaratnya biring ini kan penahan, Pak. Jadi harus ke sini. Ini W biringnya atau F biringnya. Ini sih Pak, kalau sepemahaman saya.
Oke. Terima kasih Mas Lan.
Baik Pak, sama-sama Pak.
Gimana Mas Dimas?
Ya, terima kasih Mas Sultan. Jadi karena menggunakan kaidah tangan kanan, Pak.
Kenapa pakai tangan kanan?
Di soalnya kan dijelasin arah dan single tooth. Kemudian ya seperti itu. Arah putarannya ke arah sini. Jadi kayak hasilnya ke ini sumbu Z yang ke sana.
Z yang mana?
Yang ke sini.
Kita belum tahu itu nilainya. Yang di kontaknya berapa yang di kontaknya? Yang di kontaknya arahnya kemana?
Yang di kontaknya berlawanan, Pak. Ke sana.
Oke. Terus itu gaya yang WA, ya kan? Yang di kontak G. Yang WT sama WR. Gimana kok bisa dapat arahnya kayak gitu?
WT financial for ini dari apa? Dari mobilnya kan putarannya ke arah sini.
Mm-mm.
Berarti kalau yang ini kontaknya ke arah yang ke X negatif.
Kalau yang ke X positif, apa kalau ke X positif?
Itu yang tangential force yang oleh wampirnya.
Loh, kalau yang merah ini tangential force oleh apa?
Yang di kirinya.
Bila peta itu yang ditulis di situ kan di worm-nya itu.
Hmm, yang mana?
Ya, tangential force merah itu kan arahnya sama seperti yang di Solman. Itu kan untuk worm, Thomas.
Ya.
Nah, ya. Terus untuk yang gear itu tangential force-nya kemana?
Oh, untuk gear ini mungkin ke sini.
Kalau ke sana sama seperti thrust force-nya worm dong.
Eh,
Axial
ini
force-nya
apa
worm tadi kan ke sana juga.
ke di sumbu Z ini.
Di sumbu Z ini, oke, setuju. Arahnya kemana?
Itu
Kan yang merah ini kan punyanya axial force worm. Terus next question-nya itu tangential force-nya gear. Kan kalau nggak boleh kan arahnya sama-sama di merah. Kalau sama nanti nggak jadi kontak dia. Jadi ban meluncur,
hmm,
bleeding nanti dia.
oh, berarti arahnya ke sana ya, Ustaz?
Hmm. Nah, oke. Sekarang oke, katakanlah ini yang di Solman itu yang Solman itu Mas, ya maaf, maaf. Di free body diagram itu gear sorry, force at the worm. Ya. Nah, sekarang kamu gambar di tempatmu, di gambar annotedmu ini, force at the gear.
Hmm, uh, this is a tangential force in gear.
Oke, pinter. Terus,
Kemudian untuk radial force-nya arahnya ke dalam.
oke, setuju.
Dan axial force-nya harusnya eh,
Harusnya sepanjang sumbu apa?
sumbu X.
Harusnya sepanjang sumbu E. Berarti arahnya tapi harus berlawanan kan dengan yang ada di sana. Di kontek Mas, gambarnya di kontek bukan di situ, di konteknya.
Oke, berarti ini ke
Oke, sip.
oke.
Ya, jadi merah ini yang pada gear, ya kan? Yang kanan itu pada worm. Itu ya Mas ya.
Iya, Pak.
Sudah benar
Saya
nggak?
kira
Sudah.
seperti itu.
The figures of bearing A and P on the worms of symmetrical related determine what trust bearing and bending. Oke. Kalau pertanyaan berikutnya, trust bearing pada porosnya gear ditaruh di mana berarti?
Di ini apa ya? Di sini, di sini.
Ya jangan Mas, kalau gitu ya porosnya nggak boleh jalan. Ya agak ke kanan sedikit.
Agak, ya agak sini.
Oh, daerah situ. Oke. Karena arah aksialnya itu dia ke arah X positif itu ya Mas ya. X positif kan. Oke. Nanti pertanyaannya itu bukan hanya menentukan gaya ya, tapi dia juga ditanyakan bukan hanya gaya kontak ya, tapi dia reaksi ya. Berarti kan nanti harus pindah ke plane plane apa ini? ZY dan plane Itunya apa ini? Plan ZY, plan XZ gitu ya. Benar nggak? Nanti kan ada gaya reaksinya, nanti ada yang reaksi horizontal, vertikal gitu kan, radial. Coba sih dilanjutkan sih. Pakai bahasa Inggris ya.
First, we need to find tangential velocity with this equation
Oke, good.
and find the tangential velocity is p meter per second. And then we need to find a transmit load with this equation and find the transmit load is 637 Newton. Then lead angle to find a sliding velocity with this equation, and the lead angle is 4.55 degree and sliding velocity is 3.152 meter per second.
Oke.
Then sliding velocity is to find coefficient of friction in feet per minute. That is 620 feet.
Oke. Next.
Then we can find the force with this equation. The WX is 637, and this is pressure angle is 40.5 degree, and lead angle is 5 and 4.55 degrees, and constant friction and lead angle, and the force is 5,323 Newton.
Mas, Dimas, what is the relation between 5,323 with W apa itu? Pram equal to minus 600 I plus 1,300 J plus 5,000 K. What's the relation?
The relation is to equation ini apa disubstitusikan gitu Pak, terus ketemu rumus yang ini.
Enggak, 5.300 loh
Oh ini
dengan IJK itu loh, hubungannya apa? Ada hubungannya apa enggak?
Kalau yang ini apa yang 5,323 ini besarnya kayaknya kalau dijadikan ke vektor seperti ini Pak.
Jadikan apa?
Vektor.
Berarti kalau saya ingin rubah vektor itu menjadi 5,323, bagaimana caranya?
Dengan Pythagoras Pak.
Ngomong aja, Pythagorasnya kayak gimana? Akar dari 637 kuadrat ditambah 1.323 kuadrat ditambah 5.119 kuadrat. Oke. Berarti itu resultannya ya itu ya, W itu ya. Ya kan? W itu resultannya.
Bukan
Bener nggak? W itu resultannya kan? Kamu bisa gambar nggak?
Iya.
Bisa gambar nggak itu W-nya? Apa? itu kan diagonal dari balok. Kan WX, WY, WZ itu digambar. If you draw all of them, it will be equal to balok itu apa ya? Balok. Saya lupa balok. Cube itu kubus ya. Kalau terus itu diagonalnya. Jadi sebenarnya itu semua terjadi kok. Oh, semua. Saya dikasih annotate aja Mas. Saya dikasih annotate. Oh sudah ya. Saya aja Mas, saya aja. Jadi kalau lihat gambarnya tadi itu kan dia WE-nya ke sini. Terus WR-nya kemana tadi Mas punya Mas? Ke atas ya. Terus WT-nya muter ke sana, berarti dia ke sana. Ini kan? Mas, kurang gede. Bentar Mas. Saya gambar aja Mas ya. Sini WA, WT, sama WR. Ini ya. Ini nilainya mungkin nggak sepadan. Nah ini itu kan kalau digabung, nah gini ya kira-kira. Nah gini kan, anggap benar. Nanti kita bisa dapat sebuah resultannya. Resultannya itu diagonalnya ini dari sini ke sini. Ini adalah W. Yang dia itu adalah gabungan yang W itu W apa ini ya? Ini vektor kan ya. W vektor ini equal to W A XYZ-nya saya kok lupa ya. Apa Mas ya XYZ-nya ya? Z ini Z. Ini X ya. Ini X, ini Y. Ini enggak. Benar ya? Y ke atas, Z. Benar ya Mas ya? Nah, jadi kalau itu dia berarti X-nya ini kan WT ya. WT. Sambil dicek ya nanti. Kalau salah, WT itu X ya. T itu Z katanya. Oh iya benar. X apa? Kalau X berarti kan T-nya worm toh. Oh iya benar. WT itu maaf. Saya tulis agak panjang. W pram itu sama dengan WT I. I ini kan anu ya apa namanya? Unit vector suhu X plus W X habis X Y ya biasanya. Radial J plus W di sumbu Z apa? E kan? Oke, ini. Nah, barulah terus dimasukkan nilainya WT berapa? WT itu ini kan, ini pada worm ini ya. Ini pada worm. Berarti worm itu lihat yang ini kan. WT sama dengan WX. WX-nya 637. Arahnya apa? Karena XYZ-nya tadi gimana arahnya ya? Kalau nggak salah arahnya XYZ-nya oh gini ya. Arahnya gini ya berarti ya. Balik lagi ke gambar Mas. Ini kan X, Y, Z. Balik lagi ke yang tadi Mas. Nah, kan gini kan kalau dilihat dari gambar tadi. Benar nggak Mas? Ini kan X, Y, Z. Ya, nah, berarti X positif ini untuk menunjukkan X-nya positif. Nah, sementara kita WT-mu kan ke kiri, berarti dia negatif. Gitu, negatif I. Ya, ditambah WR-nya sesuai, berarti ya wis ditulis saja nilainya 1333 J. Ini worm ya. R sama dengan Y, Z sama dengan A. A itu 519. Gitu. W ini adalah ini tadi. Ini kalau di resultan satuannya ya, nilai satuan Z. Lawannya vektor dong. Opposite-nya vektor itu.
Skalar.
Oh ya, skalar. Skalar value-nya itu square root dari WT square ditambah WR square ditambah WA square. Ini tadi skalarnya, nilai skalarnya. Kalau ini bisa dilanjutkan. Nah, ini sudutnya ini apa? Ini sudutnya ini. Ya, terus sudut antara, karena dia ada juga punya pitch angle. Ini ada sudut kayaknya. Yang di sini juga ada sudut gitu. Nah, kayaknya itu tadi informasi-informasi itu yang dimasukkan ke sini. Sehingga kita bisa mendapatkan rumus ini tadi. Jadi rumus yang ada di semua helical ya, semua gear ya, mulai dari helical, bevel, worm, angka-angka yang ada sudut-sudutnya ini asalnya dari ini balok ini, dari diagonal balok. Nah, diagonal ruang dari sebuah balok itu adalah resultannya. Nah, yang lain FT, FR itu adalah rusuk-rusuknya itu ke sumbu X, sumbu Y, sumbu Z. Nah, sekarang tinggal sudut-sudutnya yang dimainkan. Nah, berbeda untuk spur gear lebih simpel karena kalau spur gear kan cuma ada dua gayanya, aksial, tangensial dan radial. Berarti kita hanya main di satu kotak saja, terus diagonal garis diagonal kotak itu yang sebagai namanya resultannya ya, skala. Oke. Oke, ada pertanyaan di sini?
Sir, excuse me, sir. I want to
Yeah,
ask something, sir.
Ya, Mas Sultan.
I already read the book and I didn't found the equation below the 1343, sir,
Oh,
in
really?
Dimas slide. Yes, sir.
Yo,
It's not.
It's coming from 1343, Mas. From this one, Mas. Oh, annotate-nya mana nih, Mas Dimas?
So it the result from substituting all of them, sir.
No, this one. Ya kan?
Oh, I see. Yes, sir.
Sebenarnya dia bisa dapat W dari sini juga gitu. Atau W dari yang tadi itu, Mas. W-nya sebenarnya dia resultannya. Ya.
Okay, sir. So depend what we have known on the problem, right, sir?
Yes, correct.
Okay, thank you, sir.
Okay, next question. Okay. Mas Dimas, do you have any question?
No, sir.
Okay, so please continue, Mas Dimas.
And then this is a vector of apa? Vektor jaraknya antara kiri sama
Enggak gini caranya. Kamu kalau nulis kayak gini, kamu harus punya FBD-nya. If you say JK, JK, you have to draw the free body diagram in terms of vector. But if you think that will be difficult for you, my suggestion is just draw it by using a simple what is this? This one should be simply supported beam, like beam with like you solve any problems in statics and mechanics of materials. Just draw the beam, and then this is a bearing A, this is bearing B, and then you see this one is X and Z, or maybe another one is maybe Y and Z, maybe sorry, should be Y. This is Y. So Z and Y, you should draw another one. You say that this maybe vertical plane. This is a vertical plane, and this is a horizontal plane. Maybe I'm not sure. It will be easy for us, in my opinion. Then you draw the force, the contact force. Which one is a WT? Which one is a WA? Which one is WR? And then from that, you can solve the traction force. That's in my opinion. But if you want to solve by using this IJK, yeah, IJK, it means the unit vector, that's okay, but you also need to draw the free body diagram. Without free body diagram, we don't understand what is this. Especially this one, R times W. It's I think it's new for all of us, yeah. R times W. W it's distance, yeah. Just be distance, yeah. Oh no, W is a force. R is distance, yeah. RAP is distance, right? This is
Yes.
this is what's this? What's this? The opposite of dot vector. Cross, yeah, cross vector. This is cross vector, right? IJK times IJK should be I times I equal to 1, I times I times J equal to K, J times K equal to I. It will be very difficult in my opinion, yeah, because I don't like a vector. But if you say that it will be easier for you, that's okay. But I need to know the explanation. This because this is a cross vector. Cross vector is IJK mas. Where is my notation? I times J times K, I times J is equal to K, J times K equal to I, K equal times I equal to J, this one. And you see here, this JK and the W is coming from the previous one, right? W is blah, 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 I plus blah, 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 J plus blah, 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 K. This is W. So if you multiply cross vector R with a W, you should consider with I times J equal to something, J times K equal to something, K times K equal to something, etc. I hope you got my explanation. Otherwise, you can solve it by using the simple two-dimension problems. Go back to slide number 2, Mas Dimas. Please go back to slide number 2. Slide number 2. Yeah, let me draw here. So here, in order to find this, so I say this is Z. This is Rx. This one is Ry. In order to find the Rz, so Rz, maybe you need Rz and Ry. Yeah? You need to draw Z and Y, YZ diagram. So it should be like this one. This is Z, this is Y, and your figure will be like this one. Here we have a bearing, another in A, and also in B. And for the force coming from the bottom going up, it is a WR, and coming from the contact to the A, this is the WA. Yeah, it's correct, Mas Dimas. This one and this one. Okay, and about the WT, in order to find the reaction for WT, we need to draw another one. So P, what is this? So P ZX, yeah, ZX. This is Z, because X is going up, then it will be going down. This is WT. This is A, and this is P. Is correct or not? X. Yeah, it's correct, right? WR. Okay, so from these two free body diagram, we can determine the reaction, right? Finish. Then we'll cut what is this? RZ, RY, RZ, RY. This is in A, another one is for P. And here is RZ, RX. This one RZ, RX. But here should be 0, yeah, because the external load only in vertical direction. And here, the RZ here should be 0 because we only consider thrust bearing in piring in A, in location A. Yeah. So here Ry and Ry here should be half of Wr because the position of the contact is at the center, right? This is 100 to another piring is also 100. So P, this is half of Wr. It's simple. Will be simple in my opinion. You know what I mean, Mas Dimas?
Yes, sir.
Okay, so I hope you can solve it again by using this method, yeah, this approach, and then you can check it with the result with the result from the solution manual that solved by vector.
Okay.
Okay, Mas Dimas.
Okay, sir.
Sir, I want to ask something, sir.
Yes.
Uh, I want to ask about the support, sir, in the bearing A and bearing B. Can I use pin support and roll support instead of two pin support, sir? Because I think it is more easy for
Oh,
us.
yeah. So yeah. Sorry. If you use pin support, but I think it's okay. Yeah. You can, of course, you can use pin and what was that? Pin and roll, yeah. Pin and roll. Yeah, of course.
Yes.
That's okay. Yeah. P is roll because it's only got the radial force. Yeah. So we can use a roll. In A, you have to use the pin because it's also has a reaction in axial direction, in horizontal direction. So it means we have to give pin support here. In the bearing, in terms of bearing, it should be equal to rolling bearing, or what else? Yeah, rolling bearing. In roller bearing, and here for this one, this is should be ball bearing. Okay, Mas. Again.
And then if we have determine the which is the pin support and then the roll support. So if uh, berarti itu ya seri apa nanti itu jawaban dari ini kayak misalkan yang pin A itu ada resultan Z sama resultan Y. Itu berarti nanti kalau misal kita merubah ya asumsi kita misal di pin A itu ball bearing, yang di B itu roll bearing, berarti nanti gayanya juga berubah juga ya sir.
Oh ya itu nggak boleh. Asumsikannya harus dilihat dulu tadi posisinya thrust bearing di mana. Pertanyaan pertamanya dijawab dulu itu. Determine which should be thrust bearing itu dijawab dulu. Ya kan? Position thrust bearing itu depend on force of direction of axial force. Ya kan? Dalam soal ini axial force-nya itu direksinya ke Z positif. Berarti kita harus pasang thrust bearing di Z positif. Nah, kalau gitu berarti di Z positif dalam hal ini poin A itu kita pasanglah pin karena dia menerima thrust force. Ada thrust bearing di situ. Ya. Oh, kenapa saya tulisnya rolling bearing? Kenapa nggak saya tulis thrust bearing? Ya, karena identiknya nanti kamu belajar di setelah UTS. Kalau we say thrust bearing, it's only can support the axial force. Thrust bearing cannot support the radial force. But in this condition, for warm shaft, it's support for the axial bearing and also axial force and also radial force, right? Yeah, because of that, we need to combination the bearing that can support combination of axial and radial force. One of them is rolling bearing. Yeah, so rolling bearing can support thrust force and also radial force. Gitu Mas Aki.
Okay, sir. Thank you very much.
Okay, another question.
Excuse me, sir.
Yeah, Mbak.
I want to make sure that in the bearing there is no tangential force.
Oh, there is no tangential force. This one, tangential force, Mbak. The XZ. This is also same with radial for the bearing. Let we draw it again. Yeah, this WT, it's also have a support kan, Rx ini, Rx. Rx ini kan equal to WT half of WT ya, karena posisinya yang di tengah-tengah itu. Tapi WT ini kalau digambarkan di sini itu kan di sumbu apa ini X ya, berarti kan dia ke sini kan, gini kan dia. X positif, maaf, X positif berarti ke sini. Nah, ini itu WT warna hijau ini. Ini hijau kok jadinya putus. Ini itu bukannya sama seperti yang RY. RY-nya jadinya positif. RY-nya ini harusnya kebalik ini ya. Harusnya gini dia. Karena WR-nya ke sana ya. Berarti dia ke Y negatif. Y negatif itu ini Y negatif itu ke sini. Nah, ini kan W ini kan W kok W lagi. RY, yang ini kan RE. Ya kan? Ini itu in terms of bearing itu sama-sama gaya radial kan bagi bearingnya itu. Kan bearing kan enggak mentransmisikan gaya. Bearing itu kan menahan kan. Menahan itu kan gaya radial yang dimaksud gaya radial itu apa sih? Gaya radial itu kan gaya ini kan. Kalau dari dalam ini radial. Ya kan? Kalau dari luar ya berarti ini radial. Semua gaya yang saya gambarkan ini namanya gaya radial kan ini. Ya, kalau aksial lain, aksial itu ini masuk ke dalam atau keluar atau masuk ke dalam. Atau kalau saya gambarkan subnya ini aksial kan ke sana atau ke sana. Ini yang disebut dengan aksial. Gitu. Jadi pertanyaan Mbak Vivi apa? Apakah dia nggak ada transmitted? Ada, gitu ya. Transmittednya ini ditahan oleh Rx. Ya, tapi Rx dan Ry itu nanti bagi bearing itu sama-sama sebagai radial force ke bearingnya. Jadi bearing ini this bearing ya, this bearing rolling bearing or ball bearing, it support the radial force. That the radial force in bearing is coming from radial force of gear and tangential force of gear. Gitu lah. Gimana Pak?
Okay, sir. That's my question, sir. Thank you, sir.
Okay. Next one. Ya, jelas ya, mudah-mudahan ya. Oke, Mas Dimas. So, you have to solve it again ya, Mas Dimas. And then just solve it again. And then we see the results. Yeah. Maybe next week you will present again. Next week, please deliver the presentation again by using this approach. Ya, Mas Dimas ya.
Oke. Ini saya stop share atau?
Ya, stop share. Thank you, Mas.
Terima kasih.
Okay, next student, Andika.
Yes, sir. Let me share my screen. Oke, sir. Apa sudah terlihat, sir?
Oke, sudah.
Oke. Problem 15.1. So this is the problem. I think we can read by ourselves for this problem. This is the given information from the problem. We know that this is ungrounded straight bevel gear set, and we have number of teeth of pinion is 20 teeth, and diametral pitch 6 teeth per inch, and so on. Next, to the analyze the problem. The question is, what is the problem rate? What is the power rating of gear set? So we have clue that based on the ACMA bending strength. So in here we have ACMA bending strength equation, and this is the output that we are looking for. So in here, this is power rating, power rating equation, and in here I need more equation to connect these two equation. This is the transmitted load equation based on ACMA bending stress equation. Okay.
So Mas Andika, so basically the equation is similar with the helical ya Mas ya?
Almost similar, but in here we have kx here.
Oh, different coefficient ya?
Yes.
We have one another add coefficient. Okay. Please continue.
Okay. Next to the calculation, keep in mind we have to search for pinion and gear, and this is start from the ACMA bending strength equation. In here we are looking for the stress, allowable stress, because in here we have allowable stress to connect the equation. So our goal is this allowable stress. Start with SAT parameters. In here, I assume that this is the grade 1. So I use this formulation. Maybe this Excel is seen, sir?
Yeah, I can see the Excel also.
Okay. Okay, start from this ACMA bending strength. SAT with this formulation, I get the value is 15,300 psi. And next to the KL, we have to looking for the pinion and the gear. For the pinion, we already know the life cycle for pinion is 10 to the power of 9 revolution. So it is in this range. So I use this formulation to get the KL for pinion. This is the value I get. And then for gear, this is some different because we know the given information is for pinion life cycle. So we have to define the for gear life cycle. So this is I get the value here, and using, because the value is in the same range, I using the same formulation too. And then for SF, we already know the value is 1. For KT, I assume that it is 1 because there's no information about. Where's this 0.999, so it's in this range. I use this formula and I get the value of KR is 1.25. So we already get all the parameters, so we can get the value of allowable stress for pinion and for gear. Okay. Next, to the transmitted load equation. Okay, let's. Okay, we have the allowable stress from previous calculation, and F already known. Kx is 1 because of this is straight bevel here, so the value is 1. For GP in next slide. In here, we calculate for kV first. Okay. This is the formula I use. Vt using this formula, V diameter of pinion and the rotation, radial velocity of pinion divided by 12. So kV, we can get this value for from this formulation. kV already kV done. Assume that the value is 0.247, and for gear have 60 teeth and the mate is 20 teeth, so the value is around 0.20. In here I assume that 0.203. Okay, for G is done, and diametral pitch we are already known. For diametral pitch is 6 teeth per inch. KO we already known is 1. KS and KM. KS because of the diametral pitch is in this range, so I use this formulation and I get this value. Sorry. KS. I get this value using this formulation. And for KM, because of we are not using SI unit, so I use this formulation. This KMB value is 1.1. Because of this is one member straddle mounted, we know from the problem the pinion is mounted outboard of its bearing and the gear is straddle mounted, so it one member straddle mounted. Okay, and after that we get all the parameters and we can find the transmitted load. The value is like in here, and then after that we can get the power rating. Transmitted load we already calculate before, and for velocity using where is it, this equation.
Okay, so the transmitted rate should be 16 and 13, yeah, Mas, ya?
Yes, sir.
It's based on ACMA
bending strength.
bending strength. Okay, so Mbak, who is the next one? Mbak Agnes, ya? Mbak Agnes?
Yes, sir.
Mbak Agnes, you already saw for ACMA resistance, ya? Oh,
Heating resistance, yes, sir.
Oh, but different problem ya, Mbak ya. Oh iya, different ya. Sorry, different. Oh, I just did, I just thought that it's the same. Different ya. Oh, sorry. Oh, different. Okay, so then what happened? Akma pending. Yeah. Have you checked it with solution manual, Mas Andika?
Yeah, I have checked it little different. Sorry, sir. I open it again. Waduh. Jangan coba. Waduh.
15.1 ya.
Waduh, 16. Okay. The little difference is in G values. I'm not sure this is 0.216 because in here it's still around 0.20 and it's below 0.21.
Oh, below that. It depends on the number ya, number of 60 and 20 ya, numbernya ya. 60 and 20. Okay. 20% normal pressure angle and 90% soft angle. Normal pressure angle-nya 20 ya, Mas ya? Your problem.
Normal pressure angle.
Your problem. Your problem 20.
I remember it's 20. Yeah.
Oh, yes, okay. So the difference is only in this G. Yeah.
What I remember is yes.
Okay. So
just this G.
The value for the pinion, the rate power should be different also, yeah.
Yes.
It's a little bit different, yeah.
Yes.
Could you open again the solution manual?
Okay.
Let me see the horsepower. 14 and 16.
Oh, and 14.
Oh, 14. Okay, that's okay. 40.8. Okay. The gear controls the bending rating. Okay. So let me see the solution for 15.2. I wanted to see the horsepower. The horsepower. 11 and 12. 12. Okay, so could you give some conclusion? Yeah, if we consider both of them, ACMA bending and also ACMA surface, and then we got the rating rate power, yeah, rate power from both of them.
Okay.
Around 11, 12, and for the surface 11, 12, and from the bending from your Excel, it should be around 13, 16. So what's the meaning, Mas Andika?
What's the meaning?
Which one is more dangerous? Yeah. Which one is have to consider in order to find the okay. After you know this four value, Mas Andika. After you know this four value for rating value. So now if I have I want to transmit the power. I want to transmit using this bevel gear for how much? 10 maybe 10 horsepower for 10 horsepower only. 10 horsepower. 10 horsepower. Yeah. Can I use your gear, your bevel gear, Mas Andika?
Yeah, of course.
Yes, of course. Okay. Then if my need is around 20 horsepower.
20 horsepower. No, you have to
No, because the
looking other gear.
looking other gear, or you need to modify it, right? You need to
Modified,
modify
yes.
the gear.
Yeah.
Okay. How about, so now my my need now, so around how much, yeah? 14 horsepower. What happened?
14.
Mm-mm.
14, I think this gear will fail because of wear, because here just 12 horsepower. So.
Just 11. Oh, yeah, 11
Uh,
and force, yeah. 12.
yeah,
Yeah.
yeah.
Okay, so we cannot use this bevel gear, yeah, Mas, yeah.
Yes.
Oh. How about berapa lagi? 11.5, 11.5 horsepower.
11.5. I think no too, because in here is
Oh, yeah.
11.
Okay. Okay, so your baseline now is your baseline is depend on the ACMA surface, right? ACMA wear, right? Not ACMA bending, yeah, Mas, yeah.
Yes, yeah,
Because
because it's
the
more
horsepower is
critical. Yes.
smaller and longer. Is it also happen for the helical, Mas Andika?
For
In helical, the result from the ACMA surface or ACMA wear always less than ACMA bending for the power rating. Did you still remember?
Little bit forget about the value is always below or no.
Okay.
But the point that I get, we have to consider the critical ones.
Okay, the critical one. So okay, so based on your result here, the critical one is surface, yeah, the surface condition, yeah,
Yes,
the
surface.
surface are the aware. Okay. Okay, thank you, Mas Andika.
Okay, can I stop my share, sir?
Oh, wait. Is there any
Okay.
questions? Any questions?
Okay.
No question. I think it's already clear. Okay, you can close it, Mas Andika. Thank you very much.
Okay, thank you, sir.
Okay, next is Mbak Agnes, ya. Invite.
Let me share my screen.
Oh iya, sebentar ya Mbak Agnes ya. Saya untuk yang warm gear tadi saya barusan ingat apa itu single thread warm itu bukan berarti nanti di dalam warm gearnya itu cuma satu putar gitu aja ya. Single thread warm, double thread warm, triple thread warm yang sebagai end warm itu loh. Ingat nggak pelajaran kan yang jumlah gigi warm sama dengan yang dimasukkan ke rasio jumlah gigi warm dibagi jumlah gigi gear itu kan. Kalau tadi soal-soalnya Faisal sama Salwa tadi kan Faisal benar ya, itu tadi kan cuma satu kan dia single thread, itu bukan berarti nanti cuma putar satu putar gitu aja gearnya itu bentuknya apa namanya screw itu kan kayak baut gitu kan, screw itu banyak gitu. Nah single thread itu maksudnya bukan jumlah gigi, tapi single thread itu lintasannya jumlah giginya masih banyak. Nanti kalau nggak salah namanya face width ya, tadi Mbak Salwa tadi ngitung ya, coba dicek lagi ya. Face width-nya itu nanti yang membatasi jumlah giginya, jumlah ulirnya. Tapi misalnya kamu punya worm, terus dihitung ulirnya ada berapa? 10. Berarti ini end worm-nya 10. Salah. Menentukan end worm bukan dari ngitung jumlah ulirnya, bukan. Tapi dia dari tipenya. Tipenya dia apa? Single thread, double thread, atau triple thread. Itu tipe itu nanti start ulirnya sama akhir ulirnya itu di mana gitu. Dibaca di bukunya. Kadang-kadang sering kelirunya di situ. Itu yang membedakan worm dengan gear yang lain. Jadi menentukan jumlah gigi wormnya itu Dia nggak seperti gigi-gigi yang lain. Oke, silakan Mbak Agnes.
Okay, so the questions here, we given uncurrent straight people opinion, which has 22 feet. So the number of feet of the opinion is 22, and then here the number of feet of the gear is 24, and then we given the module is 4 millimeters, and then the transmission accuracy number is 5, or QP is 5, and then the Brinell hardness is 180 for both pinion and gear. The shaft angle is 90 degrees. The pinion speed here is 1,800 revolution per minute. The face width is 25 millimeters. The normal pressure angle is 20 degrees, and live coil pinion is 10 to the power of 9 atau 10 pangkat 9. Then and the reliability for R is 0.999, and the given condition is that this is a straight bevel with uncrowned, and then both through hardened steel, both have hardnesses of 180 Fresnel, and both have an outboard mounting, so there's no shaft that extends in the middle of pinion and gear. So the mounting is about. Then we have to find the power based on ACMA pitting resistance. To find the power, we use these equations from equations 1336, where the power is equals to transmission load times phi times diameter times speed divided by 16,000. So the difference here between mine and Andika is I am using the equation with SI unit. So we divide it with 60,000. And then to find the power, we need the transmission load, which we can find using this equation. And we also have to find the other parameters first. So first we find the safety factor since it straight bevel. So the safety factor is 1. Then the contact safety factor is square root of 1 equals to 1. And then for the temperature factor, we also use 1 for straight bevel. And then we find the diameter for the pinion. We got the diameter equals to 88 millimeters, and for the gear, we got the diameters equals to 96 millimeters. And then we find the dynamic factor. So to get the dynamic factor, we also need to find the pitch line velocity. The pitch line velocity, we can use the equations 15.7 using these equations, and then we got the velocity equals to 8.29. After that, we calculate the dynamic factor here, and I got the dynamic factor equals to 1.6630. And then after we got the dynamic factor, we find for size factor for pitting resistance. So here is also the difference. Since we base on pitting resistance, we use the size factor for pitting resistance as well. So since the phase B is with we're given 25 millimeters, means that 25 millimeters in between this range. So we can find the size factor using these equations. Then we got the size factor equals to 0.56. And then we find the load distribution factor from the problem. We know that both have an outward mounting. That means neither of one of them is straddle mounted. So we can assume that the J and B here is 1.25. And then we calculate using these equations here, and we got the load distribution factor equals to 1.2535. And then we find for the crowning factor for pitting resistance. So for pitting resistance, since in this problem we have uncrowned tip, so we use pitting crowning factor equals to 2. And then we find the pitting resistance geometric factor by looking at this figure. So we know that the number of pinion tip is 22, so it's around here. And then the number of gear tip is 24, so the curve can be like around here. And then I got the intersections atau perpotongannya around 0.066. So we got the pitting resistance geometric factor equals to 0.066. And then we find the stress cycle factor for pitting resistance. So we consider the 5 goals, since we given the like goals equals to 9 to the power of 10 to the power of 9, means that 10 to the power of 9 is between this range in the bottom from equation 15-14. So we calculate the stress cycle factor using these equations, and we got the stress cycle factor for pitting resistance, or ZNP, equals to 1.0001. You can say it's 1. And then for the hardness ratio factor, we take a look on figure 1510. So we know that the Brinell number is 180, both gear and pinion. So from the from figure 1510, if the Brinell number of pinion divided by Brinell number of gear less than 1.2, the hardness ratio factor is equal 1. So we got the hardness ratio factor equals to 1. And then we find the reliability factor. So we know that PR is equals to 0.999. Then we got the reliability of stress is using these equations on the top. So 0.5 minus 0.25 log 1 minus R, and we got the KR here 1.25, and then the reliability factors is equals to square root of KR. So we got the reliability factors equals to 1.118. And the last one is the steel elastic coefficient. Since it is a steel, so we can use the elastic coefficient equals to 190. After that, we got all the parameters here to calculate the power. So for the pinion, first we find the allowable contact stress, which we can use these equations 1522 using grade 1, and we got the allowable contact stress equals to 585.89 MPa Pascal, and then the permissible contact stress number, we can use these equations, and I got the permissible contact stress number is around 524.45. And then we find the bending load using equation 15.1 here for SI units. And we got, I'm sorry, it's a transmission load. The transmission load is 473 kilonewton, and then we can calculate the power from the calculations that we get. And for the pinion, we get the power around 3.92 kilowatt. It is also work the same as the gear, and we got the power around 3.9 kilowatt.
Okay. Okay. So the difference between power in gear and pinion is around point
0.02.
0.02. Oh, it's similar here. 3.9, 3.8 and 3.9. Yeah.
For the pinion is 3.92.
Oh, 92. Okay, okay. Yeah, that's okay. That's okay. And for gear is 3.9 something. Okay. So have you checked it with solution manual, Mbak Agnes?
Yes, sir.
Okay.
But there are some differences.
Which one is the different?
The power results.
In your result is 3.9 in solution manual. How many?
4.9, but also
4.9.
4.9. So,
Oh, 4. Okay. So why? What happened?
maybe in calculations and pembulatannya mungkin.
Pembulatannya. Tapi kok 4.9 and 3.9 is a big difference, Mbak. Yeah, 4.9 yeah, from the solution manual.
Yes.
Okay. Okay, I think you have to check it again, Mbak. Which one is a different? Maybe from the vector or how to read the graphic, like Mas Andika before, or maybe you just miss the calculation or something. Okay, so my question is, Mbak Agnes, if we calculate again by using ACMA bending, yeah, in your opinion, by using ACMA bending, the power rating will be higher or lower than 3.9?
I think the power will be higher.
Higher. Then, if the power rating by ACMA bending is higher than ACMA surface, which one we will use in order to define that this is the maximum power for this for the bevel gear is this value. Which one we will use? ACMA bending or ACMA surface? Let's say from the ACMA bending we got 5 horsepower. Yeah, 5 horsepower from ACMA bending, and ACMA surface is 3.9. So which value do you will use? 3.9 or 5 in order to define the power rating of the gear?
Maybe the bending.
You mean 5 horsepower?
Yeah.
Okay, so it means if I want to use this bevel gear by transmitting 4.5 horsepower, then it will be okay. 4.5 horsepower, then it will be okay. Please give.
Maybe I think it depends on the horsepower that we need. And if the bending, if it based on the ACMA bending, which had power 5 kilowatt, and then what unit is around 4.5. I think it's still fine, so
still fine. Yeah.
Maybe it could fail like later.
But from the ACMA surface is 3.9, but only 3.9 from ACMA surface. Agnes, can you give me a noted permission?
Oh, yes. Tensor.
Okay, thank you. Yeah, let me type here ACMA surface. Yeah, the power rating. Power rating from ACMA surface is 3.9 horsepower. For example, from the ACMA bending, yeah, 5 horsepower. So now I have 4 horsepower. I need 4 horsepower. Can we use the bevel gear here? You said that okay. Yeah, Magnus said that okay, we can use this bevel gear to transmit 4 horsepower because it's less than power rating from ACMA bending. So then my question is, what happened with this 3.9? The 4 is higher than 3.9 for the power rating from ACMA surface. Is it will be fail or not, Magnus? Is it okay or not?
Maybe it's still fine, but lama-kelamaan mungkin akan fail.
Gitu. Oke.
I think so, yeah.
Karena angka 4 dan 3,9 beda sedikit gitu ya.
Iya.
Kalau angkanya 4,8 juga sama. Oke, lama-kelamaan akan fail.
No, I think will fail
Or will be fail.
since it has like a higher power.
Oh, okay. Okay, that's okay. Okay. So we have to reduce our need, or we have to increase the power rating from ACMA surface by modify the materials or by modify the geometry, the phase width, and also change the materials, maybe the hardness or the material types, and then it will be higher. Maybe going up to 5, maybe. Then we can use this 4.8. Yeah, horsepower. Okay. Okay. Thank you, Mbak Agnes. Any questions? Any questions from other students? No?
Maybe not yet, sir.
Okay, thank you. Mbak Agnes, you can close the share screen.
All right, thank you, sir.
Okay, I think that's all for today. Next week is 13 October. Next week we will continue maybe for another problems related to the worm and bevel case, or maybe you have the problems, you also can ask to me, send it to Mbak Vivi, and then we will discuss it next week. Of course, you also need to prepare the answer, yeah, not only the problems. you have the problems, and then you already try to solve it by yourself, and then we need to check it together. Oh, that's okay for us. But if you don't have any answer and then just give me the question, then it will be problem for me, right? For me. So okay, that's all for today. Thank you very much. Sorry if there's any mistake, any error during this presentation, during this class. Sorry. I hope all of you are still in a good condition, healthy conditions. Okay, assalamualaikum warahmatullahi wabarakatuh.